Okay, thank you. Thank you for listening. I'll keep this short since I'm between you and lunch, and I think our biological clocks are telling us it's lunchtime. I don't know how to advance my slides. Just there's no green button. Oh, there we go. Okay, great. Thank you. So STL. For me, this is the most exciting thing to come out in 30 years. I think back when I was a young engineer working in radar and we were looking forward to the GPS system coming up and saying this is going to change how navigation is done, and it did. So I think as you heard all morning, the issues with GPS is a great system, but it's got vulnerabilities. Well, I think we have a way now of at least one way of augmenting it in that. So let's go. There we go. So it's a new signal. It's available today, as you saw in the video. It's being broadcast on the Iridium satellites. It's being broadcast today. And that deserves repeating, because I think if you all watched the launch last week, it was pretty exciting. The SpaceX launched. There's new Iridium satellites going on, and this signal will be on those new satellites as well. But on satellites that are operating today, this STL signal is there. As the video said, it's stronger. 30 dB, in the RF world we talk in dBs, 30 dB stronger, which gives you two things: the higher jamming and interference resistance, and that it operates indoors. The second factor is it's encrypted. And so what you have there is inherent anti-spoofing. It'll be delivered as a subscription service. So you'll get the encryption keys as a subscriber to this service. You get the encryption keys, and then it'll be available. So this is military systems are encrypted. Now this is the first time that we can have like a civilian system that's encrypted and have that security thing. As you saw, the reason being of the stronger signal is these are low Earth orbit satellites. So you're much closer, and so 30 dB equates to roughly 1,000 times stronger signal than what you're getting from GPS, and that's the big advantage. I did this a little comparison to show roughly the kind of, you're getting both time and location from this signal. It's not as accurate as GPS. So we're on the order, and I'll get into a little bit more of those numbers of what we have. I'll show you some more, but it's not as accurate. It is traceable to UTC, but for this industry, for a lot of industries, for a lot of our infrastructure, this level of accuracy is more than sufficient. So there's also location things that will since this is a timing event, I won't get into that, but look for more information about that in a bit. So how does it work? The Iridium system, if you've heard of the Iridium system, it is a two-way communication system. What our partner at STL has done is to repurpose those channels, some of these paging channels, to provide a time and location signal. And so, in fact, one of the things I really like working with our partners at STL is very conservative. They spec the accuracy at plus or minus 500 nanoseconds. And so I'll show you that in all of our testing, we're finding it's more in the 100, 200 nanosecond range. And so and there's a number of things that we're doing as we evolve, working with atomic clock holdover systems and aiding receivers that will probably even be able to do better than that. But as I said, for most applications, including what I think most of you are operating at, it's more than sufficient accuracy. Here's some data. Here's some data taken over a day's period of where we get this kind of thing, a standard deviation of 50, 60 nanoseconds. And with averaging, with holdover clocks, you can do, you can really make use of that. So more of how it works. Again, low Earth orbit satellites, you now have a more concentrated beam, higher density beam that you're receiving. That gives you the strength. These satellites are moving very fast. Since they're at a low Earth orbit, they're moving very fast. So unlike the 12-hour period of an orbit that you get from GPS, this is more on the order of 100 minutes. And as I mentioned, it's all encrypted. I'll say the main purpose, main advantage of having the stronger signal is the resistance to jamming and interference, because that's a thing that you're fighting all the time with GPS. But a secondary advantage is you can work indoors. And so I say, in fact, here's a typical situation. We're indoors right here. It's a pretty, we're probably in the most difficult urban canyon in the world here in Wall Street. And yet right here on our little demonstration, we are getting a signal. We're getting a sync signal. It's a weak signal, so you're not going to, like all indoor operations of anything, it won't work everywhere indoors, but here is a pretty difficult situation, and we are getting synchronization from the STL signal. So quite an advantage, and I'd say this industry, more than any of the other industries that we serve, as we make time servers as well, especially when they're in urban environments, the placing of a GPS antenna is very difficult. It can be very expensive, so could be a good advantage for you folks as well. So, I guess just to repeat, you're getting good time sync. You're getting the potential of deep indoor penetration, like we're seeing here. And there is an area, the fact that now you have an encrypted signal and you've got now trusted location. There are things that can be done in security. And so, again, this is not the subject of this conference. This is about time sync. But I think a lot of you folks are working in cybersecurity, and that there is a way of using a whole nother trusted location, that the fact that I have a known location and I can trust the location that I'm getting because I'm getting it from an encrypted, authenticated source that can add to security. So look for that in the coming months and more talk about that. So as was said earlier this morning, you have the way all of us have been serving time, these time servers, these grandmasters, as was described this morning. We're typically using GPS, and we use holdover atomic clocks to handle GPS outages. Well, now we've got a third thing, it's STL signal. Can augment these clocks, can give you that level of assurance. So during the break, we've got a setup over there. Please come over and ask any questions you have about that. Thank you.